Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is split a string into maximum number of unique substrings. Okay, so the problem statement goes like this: that you will be given a string S, okay, and you have to return the maximum number of unique substrings that the given string can be split into. Okay, and you can split a string S into any list of non-empty substrings. So basically, the substrings that you will be splitting this particular given string into should be non-empty, and the concatenation of all of them should be forming the original string. Okay, so in a way you have to place kind of you can say cuts. Okay, so what you have to do is you have to somehow place cuts. Okay, and let's say this is one portion. Okay, and this is another portion, and this is another portion. So how many such a maximum number of unique portions can you achieve? Okay, this is what you have to return. Okay, and none of these portions or should be basically empty, so it cannot be like this. Okay, this is not having any size of its own, so it should be non-empty. Okay, so it's like splitting something into pieces. Okay, how many unique pieces you can have, and pieces here are basically the substrings. Okay, so then however you must split the string such that all of them are unique. Okay, so the pieces should be unique. No two substrings that should be same. Okay, a substring is a contiguous sequence of characters within a string. Okay, so I hope it is clear. And then before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of this particular string will be of order 16. Okay, and s contains only lowercase English letters. Okay, so 16 length string will be present at max. So let's see how we can solve this. Okay, for that what we will be doing here is, let me clear this. So see, since the size of the string is limited to 16 only, so consider a situation that this is the string that is given to you. Okay, and string is basically a sequence of characters. So let's say these boxes are having some characters. Okay, like A, B, C, D. Okay, and something like this. Okay, so let's say you want to take some portion out of it, or take a substring out of it by splitting it. Okay, so what you can do is you can place your starting cut here. Okay, because obviously this portion will be going to some of this part will be going to some of the portion. Okay, so then let's say this is the starting point of the current portion, start point of, let's say, current portion here is, it is substring. Okay, so basically you can take as much as size portion that you want up till the size of the string. So for rest each of these, okay, they can serve as the, you know, end point of the portion. Okay, each of these for each of these you are essentially having two choices. Okay, okay, for each of these two choices, either it would be included in the current substring that you are forming or not. Okay, so based upon those two choices. This kind of choices would be available for every uh, basically index. Okay, and so in total 2 into 2 into 2, something like let's say this was a string of size n. Okay, so this would be n times. Okay, and it will result into 2 raised to power n. Okay, and then let's say, for example, you decided to place your portion ending point here. Okay, and so this is the portion that you are trying to take. Okay, for the current split that you are trying to make. Okay, and the rest of the string will again be having the same kind of procedure. So you already took one portion out. Okay, and you would be repeating the same kind of procedure again for the rest of the string to take portions out of that. Okay, so it would result into a kind of a recursive problem. Okay, so once you took something out of the string, then again you will do say the same procedure. Okay, so this would result into a recursive thing. So then uh, l- even to form this particular portion, so see, substring is nothing but contiguous characters of the string as mentioned in the problem statement. So in order to form this substring, you would be requiring order of n basically time complexity, extra time complexity. So the overall time complexity or a loose upper bound on it can be order of 2 raised to power n into n for making substring, and this much number of choices kind of you will be having. Okay, so 2 raised to power 16 and into 16. Okay, and it is somewhere close to 10 raised to power 6. Okay, so 10 raised to power 6 basically there is a operation limit. Okay, so order of 10 raised to power 8 operations, you can call it ops limit. Basically, if the number of operations that your solution is requiring to solve a particular problem is well within this limit, less than that, then your solution will be for sure getting accepted. Okay, and it you need not to do any kind of optimizations here. Okay, so a kind of recursive or basically to explore all the possible outcomes, you would be using a backtracking approach. Okay, it is nothing fancy. What you would be doing here is, let's say you started from a certain point. Okay, and let's say you took the string, let's say the string is something like this, you took up till here. Okay, then again you would be making some choice, and based upon that you would be going somewhere, let's say. Okay, and then after a certain point you hit the end point and you cannot proceed make any decisions further. Okay, then what you would do, you would take one step back. Okay, return to this particular state and see if there are any other possible ways to go. Okay, so this is a kind of a backtracking approach. So you trace back your steps or the decisions that you already took. Okay, and you arrive at a state, uh, if you are at a end point, then you go to one decision back and arrive at a state when you made that decision, and instead of making that one, you will try some other possible decision that you could have made. Okay, so this is what backtracking is. If you are trying, I have given a very layman definition of it, so you should definitely head over to the description box if you are not familiar with backtracking. Okay, and link of an article will be provided there explaining what backtracking is, and some more stuff on it. Okay, so then once you are pretty comfortable with it, then only I will suggest you to proceed forward this with this solution. Okay, so basically the whole thing was to observe that how a particular technique could be helpful here. Okay, so the reason of using backtracking and it would be successful is that our time complexity for backtracking would be this much. Okay, order of almost close to 10 raised to power 6 operations, and it would be less than the operation limit. Okay, So we can apply that, and let's see how we have applied this approach. And for that I will be taking the implementation to the board. Okay, and let's take the code here. So this is the implementation. I hope it's visible enough for you. So what we would be doing here is, see, since the strings that we will be splitting our original string, the substrings that we will be splitting our original string into should be unique strings. So in order to make sure that we are the current portion that we are forming is the unique one in the current split combination that we are considering, so we would be using a unique strings set. Okay, so it will only be storing unique strings in it. Okay, and it will not allow duplicates. Okay, this is the whole reason of using it. Then we will be making a recursive call. Okay, so we have defined a recursive function. Okay, so as I mentioned that you would be starting at some point, which will be your start point for the current portion that you are trying to make. Okay, so this is that. And then uh, you would be definitely choosing one of the endpoints. So this was your endpoint while you were trying to make the current portion. So this was your endpoint. Okay, so you will pick one of these indices as your endpoint. Okay, starting from your start point. Okay, and since the substring functions in Java works like this, so it should be at least, and we, since we are not allowing the empty portions, so that's why we are starting from one index ahead of the start index. Okay, so that it should be at least of size 1. Okay, and then we will check the all possible end index that we can take. Okay, and let's say we agreed upon a certain value of end index. Okay, and let's say it was that this particular situation that we took this much portion only. Okay, and uh, the rest of the string basically would be again having to face this kind of recursive choices again. So you would make a recursive call for the rest of the substring, or the rest of the string that you need to make portions out of. Okay, so then this recursive call will only be made if the current portion that you have made is a unique portion in the current number of portions that you are trying to make. Okay, so if your unique substrings uh, set is already have already not seen this kind of portion before, or this kind of substring before, then only you would allow the recursive call. Okay, so basically the very first thing that you would be doing is you would be telling your unique strings set that, okay, this is the unique portion that we have formed, and just to let you know, so that next time you will not allow this kind of portion again. Okay, then you would make a recursive call for the rest of the string for this particular yellow portion. Okay, and once you have made that call, and you have explore all those possible outcomes, then again see what you have to do is you have to basically undo your choice that you have made right now. Okay, in order to explore other choices for the end index. So for kind of undoing your choice, you would be removing the current portion. Okay, so you will be instead of the current portion that you have formed, you will try to form some other portion at the current step. Okay, so for that you are kind of removing or taking that entry out of the unique strings. Okay, so once you have taken that out, uh, th- then you will do some other exploration. Okay, of the possible end index of the current portion that you are trying to make. Okay, and this whole thing will continue, and once you are done with all this, then basically we forgot to discuss this base case. So the base case would be that your start index is basically at the size of basically you have exhausted all of the indices, or the number of portions that you are trying to make the from the given string are complete, so you cannot make any portions further. okay, or any substrings further. So in that particular case, at that point of time, whatever will be the size of the unique strings set, how many depending upon how many unique substrings you have seen till now, that will be your size, or that will be your current maximum substrings. Okay, so maximum number of substrings that you can split your string into. Okay, so you will be updating your maximum substrings value, okay, by the size of the unique strings. Okay, so once you have done this kind of updation, uh, when you will be done with all these calls and exploring all these possibilities, then you would be simply returning your maximum substring counts. Okay, so the maximum number of substrings, unique substrings, that you can split the current string into. Okay, so you would be returning that. Okay, and we already discussed the time complexity part. The time complexity wise, this will be n into 2 raised to power n, or for simplicity you can take it as exponential only. Okay, so since n is 16 only, so it will not be mattering that much. Okay, so anyways, then space complexity wise, it would be order of n only. Okay, because either you take into consideration the recursion stack that you would be using, or the entries in the unique strings that will be there. Okay, so if n is the size of the string, so these will be the complexities, and this is the approach and the complexity analysis. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section, and I really hope this solution walkthrough added some value to your journey of honing your DSS skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.